Okay, so welcome to Unit 2. The first part of this is going to be a little bit of a review and then some new material. But before we get really rolling into Unit 2, it is worth it to take a moment to kind of make sure we really understand what's happening with our wire color conventions. Mostly because you're about to start working with the Teensy and the Patton Robotics motherboard. And this Teensy is, about $20, and the motherboard is about $18 or something like that. And what I don't want you to do is plug things in incorrectly and short out either one of these. All right? So it's well worth it to get into the habit of making sure you understand which colors and what it designates. So this shouldn't take long. We'll go over it real quick because we have done this before. But if we start off with just the wires we've been using for breadboarding, they actually come in a lot of different colors, but what you want to try to do is you want to try to stick with some primary colors if you can to designate their function. So the two most obvious are going to be like the red and the black. Okay? If I had my choice, you'd have lots and lots of red and black in the kit, because every time you hook up power, you should be using red, and anytime you hook up ground, you should be using black. Okay? That would be the preferred choice. And if I ever see a red wire, I'm going to assume that it's a hot wire. If I see a black wire, I'm going to assume it's a ground wire. And it's a good reason to get into these habits. Although the power that we're using is pretty slight, and there's not a lot of current, you're not going to get anything more than the mildest of shock, if anything, with the circuits that we're building. But if you were working with, for example, my electric car, and you inadvertently did something with this wire, cut it or placed it incorrectly, it has enough power to weld with, and it would easily kill you. So it's a good idea to stick with, standard color conventions so we can automatically recognize it. But that being said, we don't have all those options available because we are using a kit. And so we have other colors to deal with. So as a rule of thumb, you want to use your darker colors through green to be your ground. Okay? And I prefer the reddish shade colors to be power, right? So in this case, the red and the orange. And then anything hooking up to a signal that controls either to the processor or some other device, you're going to use your lightest colors within your kit to designate the signal wires. Okay? So if you stick with this, it'll make it easier to diagnose and to troubleshoot and to anticipate what it is that everybody's working with. So that being said, we'll get these guys aside. We're going to start working with this guy here real soon. And we're going to stick with that same sort of scheme of colors. And one of the nice things is that we will have a lot of these, which are great because it's kind of a no-brainer. We've got 3 colored wires already wound together. And this is actually color-coded in such a way that it shouldn't be hard to figure out that the yellow goes with the yellow, the red goes with the red, and the black goes with the black. And then you're going to, invariably hook it up correctly. Okay? So always have your lightest color wire closest to the chip and your darkest color wire closest to the edge. So if you're on the other side, spin it around. Yellow to yellow, red to red, black to black. So now my yellow is closest to my chip. There are a couple other 3-color wire devices in color shades that you might find. For example, these servo motors of this type tend to have a slightly different arrangement, but the same tendency. So we go from orange to red to brown. So just like this guy here, you're going to have your lightest color toward the chip and your darkest color toward the edge. So this is going to go in like this. So the red lines up perfectly, the orange goes to the yellow, and the brown goes to the black. Okay. Likewise on this side, just like this. All right. Now, the other things we run into from time to time, perhaps more so than I'd like, is we do have quite a bit of these cables that are zip-off. So you rip off 3 or 4 wires or one at a time, and you end up making some of your own strips. Or there are even some of these floating around, which are pre-made little zip strips. So you can see that this right here, this red, orange, yellow was zipped right out of the middle here where we have this red, orange, yellow. And it was fixed with these 2 ends so that we have a 3-pin instead of a 1-pin like these guys. So you have a tough choice here, but I would still tend to go with my lightest color toward the chip. Alright, so in this case I would prefer it to be like this, so that my lightest color is closest to the chip. The yellow does line up with the yellow, but unfortunately in this case we have red on black, which is obviously not a desirable configuration. I would avoid using this wire if it's in your toolkit, but if you have to, you have to. Just try to keep a standardized method. Just try to keep organized with your wiring conventions. Avoid these if you can. But I know that since we're all working remotely during the COVID crisis, that sometimes you don't have the choices that you would normally in the lab. So I guess that being said, I'm going to pause this and set this video up so we can actually start introducing this guy to you and explain all of its features. And I'll be back in seconds because I'm just going to pause it. Okay, so let's go over some of the bulk features of this board and its layout, and then we'll get into a couple of details probably in a short second video. As you've probably already sort of alluded, the color codes of these pins are designed to guide you into placing your wires into the right location. Okay, so every single one of these yellows right here wires up directly to an I/O pin on the teensy. Okay, so these guys here are direct links to these pins. Same on this side. These guys here are all direct links to these pins. Okay, so these are going to be your I/O connections, the yellow. Now notice a couple of pins have snuck in here, right? Like that red one there and this black one here. Okay. This guy here is in fact a power pin. It's a very unique power pin. I'll talk about it in a moment. And this is going to be actually another ground pin. So let's talk about the power. All the reds are going to be power, and all the blacks are going to be ground. Okay? Now what makes this power pin unique, this little guy right here, that isolated little red guy, is this guy is always going to be 3.3 volts, no matter what. This group of red pins right here, I can change it. I can set it right now with this jumper on these two pins. It's actually at 5 volts, which means that every single one of these red pins, with the exception of that one up there, is going to be 5 volts. If I move this block to right here, okay, now it's closer to the 3.3, and that means that all of these pins are going to be 3.3, which means that everything on this side of the board is 3.3. Notice I haven't talked about this side yet. Okay, we're talking only about this side right now. So this jumper controls just these center red pins right here, and then selects it between 3.3 and 5 volts. For most everything that we're going to be doing, you're going to want to have this guy on the 5 volt. For some independent project work, you may want to switch that to 3.3 volts. Okay? So now let's go over to this side. So again, same thing here, all our signal pins. All of these guys are power pins. And just like this side, it's selectable, but this time it's with this jumper. Okay? So currently you can see that this jumper block is closer to the 5 volts, which means that all of these center pins are going to be 5 volts. The other option is to move it over to what's called VN. That stands for voltage in. So if I move this jumper over to VN, then whatever it is that's plugged into this battery port right here is going to become the source that's here. Typically we use 6 1.2 volt rechargeable batteries, which means that if you're using a school pack of batteries, or one of the ones that I provided you, that's going to be 6 times 1.2 or 7.2 volts. So if I plug that in right here with this set on VN, I'm going to get 7.2 volts. If I move this jumper over here, All right. Now, even with this battery packed in, even with this battery pack at 7.2 volts, it's actually going to regulate it to 5 volts. So now this guy is only going to have 5 volts. As I said at the beginning, every single one of these black ones is going to be ground. All the male pins are all going to be ground. Let's talk ever so briefly, and then we'll end this video, about the females. Okay? So these are female sockets, and they're labeled here on the side. So you can see what we've got here is an A0 through A9. So that's A9, A8 on down. Okay? And over here, it's a little hard to see. You have to kind of, get your eyes just right. There, I think you can see 0, 1, 2. Okay? So that starts off at 0, the second one from the top, and it works its way on down to 11. Oddly enough, there is no female equivalent for 12 or 13. They're moved down here. Okay? So the female for 12 and 13 are down here. Then this becomes 11 through 0, and this becomes A0 through A9. Now, I left off these couple right here in the top because this outer one on the corner here and this outer one on the corner here are ground. Okay? So these are ground. They're actually connected to these black male pins. So that's a ground. This is connected. The inner ones are positive, and they're connected to the red bus. So this is connected to this red bus. This is connected to this red bus. That means that if this is set at 5 volts, then this inner pin right here is going to be 5 volts. And with this set at 5 volts, that means this inner pin right here is going to be set to 5 volts. All right? And this is really handy. The reason why we have mostly the ones that are most handy are going to be this ground over here and this ground over here, because there are lots of devices like this. And if we look carefully at it, you can see this outer pin is a negative. Okay? And then we get the other ones, which are going to be the LED colors. So I can simply plug this guy in with this negative pin into this corner right here, like so. And now I have already wired in this device to hook up to pins A9, A8, A7, and a common ground. Same with over here. If I plug it in like this, my ground is there. And that means that the other 3 wires are going to be hooked up to pins 0, 1, and 2. I should point out that I keep talking about A0 through A9. This is their analog pins, and that's probably the preferred reference. But we can actually give them the same numeric values as we do here. Like I said, this actually went from 0 to 12, then 13. So A0 is actually 14. A1 is 15, A2 is 16, all the way up to A9, which is actually equal to pin 23. So I'm going to end this segment, and in the next video we're going to talk about the switches, this additional jumper, and this additional bus over here to the side. And I will see you guys again real soon.